Hello again, a new day, the same project. Beautiful winter day. It's cold outside, really cold, but the sun is shining. A few clouds in the air. I hope my banners are doing the job today. It was pretty cloudy in the last time, so not so much solar production, I may say. What I want to do today is just to have a part 2 somehow for antenna testing. And first I'm gonna have this 2.5 or 2.4 gigahertz in the Nano VNA. You see, both of these are SMA female. So how can we put them together? I'm gonna improvise a pin in between, so there is no need for any other adapter. Something like this, you see? Okay, so I'm just going to put this inside here. Perfect. And then into the Nano VNA. And now we have the antenna connected to Nano VNA. You know, this one will transmit a signal on 868 megahertz. And here, the other side, I have the antenna input for my radio, RTL SDR radio. And today we're gonna test different antennas. I have a Yagi, and I have the original, what is that? And I have the original HealthTech antenna, 3.5 dB, and so on. So we can have a clear idea about the possibility. Okay, that's the original one. This one is gonna be tested first to have a clear image about the income, the gain. Let's start experimenting, okay? First, I'm gonna have my Nano VNA set on 868 megahertz, because this antenna should be working now with 816 megahertz. And there we go. It's on. Let me have the radio up and running. Oh, this is my friend here. Huh? You like him? You should. Happy guy always. Okay. 868. The frequency is set. Let's go. We should have a little bit of gain here. Oh, sorry, there is no antenna there. Okay. There's the HealthTech antenna. Okay, so we have to do the same trick. Oh, no, I'm going to use an adapter. Exactly the same trick for getting the antennas together. Just improvise a pin. And that's the best way, because you don't need any fancy stuffs. Oh, come on. Yeah, we are good here. And let's see. Whoa. Whoa, 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 whoa. It's a lot of signal there. But like I said, look there, lots of activity in the 868. Beeps and beeps. Oh, beautiful. Okay, now I'm moving the Nano VNA the other side of the house. So we're gonna have a fade signal from a distance. Now let's see if we can reach anything with the Haltech original. No, I can't see anything, so I'm gonna change the system and go to CV, broadcasting or sending. Oh yes, you can see now it's sending a radio signal on 868. Let's put these things down a little bit. Okay, there we go. Gain to 10%. Okay, gain to 12.5 dB. You can see. So you can see the beacon. It's right here. So it's going. It's higher than 72, 70. It's reaching sometime. Oh, okay. Let's have the antenna in a proper position. Far away from any metal parts, like here, let's say. Funny. Uh-huh. Okay, so that's the position here, and it's going up to 75, maximum 74 dB. So this is the original Haltech antenna. Okay, this is done. Now 74 for the Haltech. Now let's try this one. Okay, I believe this one needs a little help. Okay, of course. I use the same trick with an adapter and the center pin. I mean female to female. And the other side here goes to this antenna, and that's supposed to be 8 dB antenna, TX900 from eByte, I think, I remember. Let's check that out. And we're going exactly in the same position. And this is funny. Look there. It's, of course, it's much better. -62, -63 even. But it needs a little bit of, let's call it tuning. -64. Okay. So this was the 8 dB antenna. But anyway, like I told you, it's funny because it needs a kind of like this. It's going to even 61. Maybe I should try that with Haltech too. You know, tilting the antenna. -61, remember that. Where is the Haltech? Come on, come on. Oh, right here, center pin. So I'm back to Haltech original, 3.5 dB, same position, tilting the antenna, and look there, -63, 64. Oh, that's amazing. Do I have something here? It's impossible to have something on the desk sending 868 megahertz. And it's reaching pretty okay, 65, -65. Okay, so they are pretty close. You know, I was really disappointed about that antenna. It should be 8 dB, but it's not at all, I can tell you that. because on the field, up on the roof, it was no result. And the last one. The last one, it's my Yagi, middle to middle, and we have the Yagi on. Okay, I'm really curious about this. Oh, yes, no doubt. So the Yagi can reach easily minus 58, and please consider this not even properly done, because this is tuned on 900 megahertz, 950 megahertz. But the results are way better, minus 59, minus 58. Okay, I don't know exactly how much is the real gain of these antennas. What I have done now is just to compare, the gain of each reported to Heltec. Of course, I have another antenna. It's up on the roof. I can take it down now. It's it's too cold outside to do that. But I think you got the idea. So that's the way how you can measure or compare antennas. So far, and I was expecting that, of course. So far, the best results is with Yagi. The Nanovna, it's in that direction. Okay, let's go the other way. Of course. But this is impressive. Okay, so this was my first attempt to have a kind of, how can I say it, of compare between antennas, between LoRa antenna for helium miners. It's a kind of empiric way to do that, but it's working. So then I can have a clear idea about how the things are running with LoRa and all these stuffs. Thank you for now, and I'll be back with some other info soon. And first of all, don't forget to have fun. Bye bye.